our next project is going to be with the laser cutter. And a laser cutter has the ability to cut a repeated 3D pattern. And I have some cardstock that I'm going to give you. I've already purchased it. We have black or gray, and you can use 6 sheets of one, the other, or 3 of each, or however you want. And we can laser cut out whatever pattern you draw. And you'll need to assemble whatever your laser cutter is on some kind of board as a finished model. Some examples, laser cutters can cut all sorts of stuff, so you don't have to use the cardboard that I give you. These are some examples of wood, and these patterns can be assembled, individual objects can be assembled over and over again to create really interesting patterns, things that you just wouldn't do by hand because it's too time-consuming. And here's another example again, and this is a real company that this is what they do. They create these panels for people. There's also traditions, cutout traditions in a number of cultures. The German tradition of Scherenschnitte, which you kind of cut out these silhouettes of little scenes, and they can be any number of ways. In this case, cut by folding the paper first. Or more artistic types of interpretations. Some of them kind of look like woodblock prints, or flowers, or other sorts of artsy-fartsy sorts of things. Again, whatever you can draw, you can cut. I've also seen a lot of examples of people using this for a kind of more architectural thing. Again, this is just cuts made in the paper, but by cleverly folding it, you can get some really interesting designs. Here's another design. It's just a matter of, can you think it through well enough to be able to fold this thing up? And this is an example of one. Again, this is just strips cut into a paper, but by cleverly folding it and now lighting it, it's really dramatic. Or something like this, which is fabric. We can put fabric in our machine. I'm not sure what you'd do with this, but we can do it. Or even thicker wood, by cutting through it, you can create a flexibility in the material that wouldn't be there otherwise. And there are people out there selling these sorts of things that kind of snap together. Again, if you cut a sheet of plastic, leaving in the little tabs to hold the objects in place, again, if you think it through, you can snap everything together and come up with some really interesting stuff. And these can be, covers for boxes or other sorts of things. You can even make a cupcake holder. And in fact, I really think this would be fun to do. And there is even an example out there of someone who puts leather in the machine and cuts very interesting designs for clothing of various sorts. And here's a light fixture. Again, materials are flexible that we can put in this machine. It's just up to you and your imagination. And I have some more ideas here on a Pinterest board that you can, waste some time looking at. And you guys are actually much more sophisticated than me about finding ways to collect inspirational images. So the big thing is you do need some kind of sketch first. With all of these projects, I want you to start with a hand sketch, mainly because I don't want you to be limited by what you can come up with on the computer. It's pretty typical. But I also want you to do a sketch model. And what I'm hoping to do is that in class, the in-class time will be spent doing your hand-drawn sketch and your sketch model. And I'll bring in some paper that you guys can cut up with scissors just to try out different shapes and different things to see if it's going to work the way you think it will work. But then once you do that, you go ahead and draw the lines on the computer. There are 2 ways that I know how to do it. One is with Adobe Illustrator, which is probably the easiest way, especially because you all know how to use Illustrator. But Revit also works fine. And so if you ever want to use the laser cutter for a studio project, you actually can print out of Revit. It's a little more complicated. Anyway, the big thing with the laser cutter is that you have to go to the machine. It's not out and available, and you have to have a lab tech there. So like the 3D printer, you have to schedule a time. And really, it's a very easy process. You open up a Illustrator document, and when you draw lines, you just have to make sure that the stroke is the correct value. 0.001 inches, or 0.072 points is the dimension for cutting. We can also engrave at the same time. With our material that I'm giving out in this project, I think I'm going to not let people engrave unless they're willing to put up with a little bit more waste, because getting the engraving just right does require some experimentation. Design considerations, things to think about. Basically, you can go online and get some folding patterns and create some really interesting stuff just using online patterns. But the other thing is you can create a light fixture. Those of you who were in the lighting class last semester, you know I have kind of a hanging pendant-mounted base that you can screw in an old-style lamp into. The dimension of that base is 1.10 inches, so if you leave a hole in your cutout, that dimension, it's very easy to screw it onto the base and it will hold together like a chandelier. Finally, going to the laser cutter, you need an approved supervisor, and you have to stay there the whole time. Some of the designs can take a long time, so just be forewarned that you could chew up, an hour or two. Within Illustrator, the biggest thing is that the largest size you can have is 16 by 12. Our project, we can go 8.5 by 11, although I think the new paper that I got is actually 12 by 12. So I have black paper that's 12 by 12, and I have gray paper that I believe is 11 by 16. So we do have a fair amount of area that we can use. A big thing with Illustrator, like I mentioned, 0.072 points or 0.010 inches. If you type in inches into the stroke settings, it will convert it to points. I think point is the default value. And I will be posting a template on Canvas with the right page setup and everything, so you can use that. The other thing is within Illustrator, you can of course change the units that are available, that the objects are displayed in. So I actually switch it to inches because I'm not really comfortable in the kind of workspace where it's kind of desktop publishing. The other thing is that when you print preview it, you have to be very careful about making sure that the placement of the image is in the upper left. And the reason is, of course, because you're now, instead of using ink, you're driving a laser, and that laser needs to start in the upper left, or else you're going to start cutting into, we can actually cut part of the machine, so this precision is very important. The other thing is that Illustrator likes to auto-rotate, so you make sure to check your print preferences each time. And again, the lab monitors will be there with you to make sure. I always make sure to check print preview also. And that's true actually for any print job. You should just check print preview to make sure you're not printing the wrong thing. And then you just hit print. Obviously choose the epilogue engraver and click on the preferences button. I'm on the Windows side, and that's what's connected to the laser cutter. And that brings up the special epilogue laser printer menu. Now these settings that I'm showing here happen to be just cutting, so it's using what are called vector settings, and that just cuts. And the speed, power, and frequency are all things which need to be adjusted for each individual material. You can't just use the same settings. So again, check with the lab monitor. They'll have the latest version of these settings that are appropriate for the materials we're using. But the ones I'm showing here are probably the ones that will work fine. You can convert a Revit file to Illustrator or AutoCAD if you prefer to draw in those. Basically, you can import a DWG file, a drawing file, into Illustrator. It's best if it's a flat non-3D file. So in Revit, go to a plan view or something like that, and you can do it. Within Revit, if you create a custom line weight, you can print right out of Revit. And again, 0.001 inches is going to cut 0.009 inches and above will engrave. And again, I don't recommend dealing with engraving, just cutting. And if you create a special line that is the cut only line, and there's a template that I put on Canvas that is set up this way, then any line you draw using that line weight will cut. Any other line will do nothing because of the way we have the laser cutter set up. And within Revit, of course, you can always change the line weights of different objects to make them be the line weight that you're hoping for, the cutting line weight. Finally, from Revit, of course, you still hit print, and you have to go to the properties, do the laser cutter settings as we've done before. The big difference now is that you need to make sure the Revit settings are correct, and Revit also has an issue auto-rotating. If you are doing things like interior elevations, for example, some people have used a laser cutter to cut the model for their projects, but they just want the interior elevation. You'll want to make sure you either turn on or off the crop boundaries, because sometimes you want to print the crop boundary for interior elevations. And that's true when you're printing for lines, by the way. Anyway, there's a number of other settings that you'll want to check. And again, always check print preview, and the lines should appear within the expected sheet boundary. Revit is actually a little bit more of a pain about auto-rotating and finding the origin. So if you're doing something complicated and you're comfortable with Illustrator, feel free to use that. Accept and run the job. The big thing is when the laser cutter is going, keep an eye on it. One, to make sure you're not starting a fire, which is strongly discouraged, but also making sure that the laser cutter is cutting the pattern in the way you think it should. Finally, for this project, you just put everything all together. You assemble your 3D print, and if it's a light fixture hanging off the ceiling, that's one thing. But however it is that's going to be assembled, assemble it. I'll also like an annotated sketch, and like before, put in a scale figure so we have a sense of how big this thing is, or some kind of dimension, And obviously, we're just making this out of paper. If you could have your druthers, would you make it out of metal or concrete or whatever? The sketch model, a good photo of the sketch model is also acceptable. Again, best photo setup is what you want for these sorts of things. Crappy little phone photos where the model is just sitting on the vinyl tile flooring is not really very good. Anyway, and then try to render this image if you can in Revit so that we get a sense of what this would be. If it's actually meant to be 50 feet tall and a divider for the post center, please try to render it that way. And you can Photoshop that if you need to. And then finally, an artist statement. And big thing with the artist statement is, what are you planning? Is this some kind of screen wall? Is this a light fixture? Is it a light fixture for a certain type of place or not? This project will not be presented until the week of March 7th. We're going to present these and the the 3D printer projects all together. Partly because it just takes some time to get everything through the system. So for next class, absolutely have your Illustrator file done so that we can get going. I just want to check everybody's file and make sure they're all right. And if you're working, if you've gotten that far, try to get a rendering also of this model. But next week we will actually just have 3D printing. We will not meet as a class. So you need to go and get the Illustrator file done so that you can take it to the lab monitor and get it printed.